Okay, cool. Hi, everyone. I hope that you are all doing okay, at least as well as you can in this strange quarantine world. I hope you're healthy and that your families are healthy and that you're getting everything that you need. I apologize for the video quality. I was trying to record this later in the day, but I just needed to get it done. So I'm a little bit backlit right now. Okay, so my plan this week is to cover a protocol called OSC. And OSC stands for Open Sound Control, which is, I think, quite a bad name for a really useful system. It really has nothing to do with sound. It has no reason that it should only be used with sound. But what OSC allows us to do is pass data between applications on our computer or over a network. So we're going to use OSC to communicate between Chuck and processing. You could also use it to communicate between Chuck and Chuck, or Chuck and Max MSP, or Max MSP and processing, or Touch Designer and Reactor. Like, a lot of things speak OSC. So you can use it to communicate between different things. And really cool thing, which sadly we can't do because we're not all in the same place. Although we usually wouldn't do it anyway. We'd say that we're kind of grid speeds and groups or something. But it's totally possible with this sort of a system to get everyone connected to the same Wi-Fi network and fire messages to each other's computers over the CalArts Wi-Fi or something like that. And a lot of really cool things can come from doing that. That said, the standard way to do it in the Chuck class is you send data from Chuck to processing or from processing to Chuck. Either way around, doesn't really matter. And that means we get to write some processing code today, so that'll be fun. My girlfriend's watching Love is Blind, so there might be strange sounds coming from the living room. Okay, so what I really want to focus on is OSC. I'm not so concerned with the rest of the Chuck patch today, or like how, like I'm gonna make some sound. I'm gonna make a patch that I think is fun and that like makes the process interesting, but the thing that I care about on your end is that you understand how the OSC part works. So we're going to make some Chuck code, we're going to make some processing code, and probably this thing I'm going to do now, which is make like a sound generating Chuck patch, will be optional for you to watch. Once it's done, I'll do all the OSC plumbing and mark some stuff in processing too and do the plumbing on that side. That plumbing is the part that's important. You all know how to write processing code, you all know how to write Chuck code. That stuff is arbitrary, right? It's the same as when we did MIDI. It's like the important part is the MIDI part, like whether it's a synth or a sampler or whatever, like I don't care, that's up to you. But the important part is the plumbing. So that's what we're gonna focus on. We have to have some code to work with, so I'm gonna quickly write a little granular thing that I think will sound fun. And I'll leave the screen recording on. I may cut this into separate videos. I may just timestamp it so you can skip around if you want. But yeah, this part is just going to be regular old Chuck Burger now. Cool, so I have set up just a folder. So I have a folder which has a samples folder, doesn't have very much of interest in it, and it has a file called OSC. Again, I'm not going to do like multiple files or anything today. So this is the sample I'm working with. I might change it if I don't like it. I was just kind of a spur of the moment choice. Okie dokie, I've got my terminal set up, and, oh no, I didn't want that, I wanted to chuck it. Chuck it! This seems to be working. So, the way I'm thinking of this is, my vague plan is I'm going to have something in processing which will have, maybe like when you click, it fires off some grains, and where you click will control the parameters of the grains. That's my like first idea. So I wanted to have a basic grain idea, grain patch that can be fired a bunch of times, and probably would just come from a sporked function. Maybe we'll do some memory management if we need to, but just to get things rolling, I'm going to create a gain, I'm going to call it bus, and chuck it to DAC. I'm going to create a function, play one grain, and this will take a sound buff, S, chuck to bus, and what is it, me.dir plus samples / silly.wave, chuck to s.read, whatever, 1 second, check to now. And let's just like to test it out before we do OSC, maybe I'll just do some basic like HID, right? So what is it, HID, is it HID, what is it, HID, how do you HID? Let's just go grab it from the mini article examples. I'm using a different computer than I did last week, otherwise I would just go grab the code from last week, but I'm just gonna grab the example, HID, keyboard, open, yeah, it is just called HID, okay, whatever. And make sure that I'm gonna get the keyboard that I want. So my keyboard 0 is my USB keyboard. Okay, so that should be fine. So if I do this, if I run this, hopefully we get some sign-offs. Oh my god, I didn't save it. If I run this, we get some events when I click keys, that's good. And for now, let's just say if message is buttoned down, we'll do spork play one grain. I don't care about the else. Don't care about these comments. Get this crap out of here. We care about that. Yeah, we don't care about that. We don't care about that. Okay. So now when I play, cool. It doesn't seem like it's going to crash anytime soon. Okie dokie, I might turn this down a little bit on my headphone. Okay, cool, so we can work with that. So let's make some arguments. I need my handy MIDI to frequency function, not MIDI to frequency, like MIDI to rate function, which I always forget how to write, so I just pull it out of something I have on GitHub. But we've given you this code before. You can grab it from there. You can grab it from here or wherever. What is it called? I don't remember what I called it. It's probably in Tasty Grains. Rate for note. There we go. So I want this function with, get out of the way, email. I want that function, tell email to fuck off. And I've somehow ended up with two windows open, so we can close that, get back to something that makes sense. Okay, cool. So we have my rate for note, which is just a utility function, so I'm just gonna stick it at the bottom so it's not like, I'm not looking at it. This requires there be an int root defined, and I'll just make the root 60. I don't know, make the root 60. And let's allow me to pass an int note in here, and we will pass, what is it called? Rate for note of note, check to s.rate. So hopefully now if I were to pass 60, we'd get the same thing. We do. If I pass 48, we get an octave down. 72, octave up, good, and all manner of notes in between. So we can do like math dot, what is it, ran to, from 42 to 72, or 48 to 72. Math is number ran to. Is it not called, is it just called random to? Love it. Love it, love it, love it. Ah, okie dokie. Let's say there is, how do we want this to actually like sound? let's run this into an ADSR E. We will set 1 ms check to E dot attack time and 1 ms check to E dot release time. And we'll kick in a while loop, and we'll make maybe some random amount of time for it to go. Maybe we'll just do a for loop to make it easier. For in I is less than math.random to, let's say it could be, we might loop 10 times or up to 100 times, I++. We will wait for some semi-arbitrary amount of time. So let's do math.random to between 10 milliseconds and 500 milliseconds, check to int t, ms check to now, e dot key on, e dot key off, 1 ms check to now to wait for the release. And we will, in this loop, at the start of it, we will make a random position too. So math.random to 0 to s.samples, check to int p, check to s.pos, key on. Okie dokie. Let's see what that does. And let's only pass notes of a major scale here. So let's make a little kind of set of offsets for major. So 0, 2, 4, 5, 7, 9, 11. At check to int scale. And we will chuck, I don't know, 50 seemed like a pretty good thing, plus math.random 0 to scale.size minus 1, and this is actually going to be scale. So now we should only be playing notes of a major scale starting at the 50th MIDI note. It's kind of off the cuff, we'll see if it actually works. Okay, it seems to work. Let's lower this a bit. Lower it even more. And I want this to be longer. Okay, not the most exciting thing in the universe, but enough to get us going. So I am now going to basically switch into processing, build some sort of a UI that might be interesting to work with this, just write some very basic processing code. And then we're going to look at how this OSC communication actually functions. Rad. So hopefully I have processing on this machine. I do. And we'll make it look nice because it's no fun to work with things that don't look nice. Okay, there's gonna be a lot of typing flubs here because I haven't run processing for a bit. So void setup, void draw. And as I've said, my goal, let's make a canvas of size, I don't know, 640 by 640. Make sure it works. Okay, cool. My goal is you to be able to click anywhere. Whenever you click, it will create a grain, and we'll have some, relationship between maybe like this left axis and right axis and up and down. The X and Y axis basically will define some properties of the OSC message we send, which will define some properties of the grain. So first, I just want to get the thing set up, so I'm going to make a background of 255, so it looks nice. And let's create our mouse pressed function. And this is a void. And how do you do this? This is, so let's say, let's just first do a print line, mouse X, mouse Y, make sure this is working. And when I click, 0, 0, thereabouts, 640, 640, or thereabouts, good, seems to work. Okay. Now, I'm thinking what I want is maybe to always draw a background that's like, we need to do that rectangle thing, huh? So let's do fill 255, 10, and rect 0, 0 width height. And this needs to be no stroke. And background 255. And then when we click, let's draw an ellipse at mouse X, mouse Y, and at some random size, float S equals random 10 to 50. And we're going to draw it with size S. Okay. Why is it not working? Because I haven't set a fill color. Fill 0. Okay, that's kind of nice. I can work with this. We can clean it up more later, but this is kind of cool for now. I would really like for them to fade out entirely, but it's not going to happen without some more intense programming. Maybe we could make this a little bit higher so they're not like so obvious. Maybe 30. That's kind of cool. So when I click, you see a little thing and then it kind of fades out. That is fine. We can do something more complicated later on, but for now, this is going to be all we need. So, OSC, we're going to look at the processing side first, then we're going to look at the chuck side. Again, doesn't matter. You can send and receive in either direction. It's whatever you want, whatever makes sense for what you're doing. If we start doing audio analysis and visualizer stuff, which we may do next week, it would make sense to do right after this. We will be doing sort of analysis on the chuck side and sending information to processing for visualization. But to avoid talking about OSC and audio analysis at the same time, as they're both complicated topics, I decided to just do a GUI this week, and then we can go the other way next week if people kind of gravitate towards this. To be honest, I don't know. I don't know how we're supposed to teach right now. Okay, I'm back after a brief break. So this is where I expect people to jump into the video if they are uninterested in the sound generation part of this week and the processing kind of GUI development part of this week. As I said in the intro, all I care about is that you understand the OSC part. So what your sketch looks like, I don't care, and what your chuck project sounds like, I don't care. All that I care about this week is that you send from processing to chuck. So, just to keep everyone in the know, if you've just joined us, you skipped ahead. If I have some file here, I have some chuck code, and I've connected it to HID just for testing, but we're going to replace this HID input with OSC input. So, oh my god. So it sounds kind of, not grainy, but it's not, it's just kind of looping a little sample. And you can see how I made it if you're interested. And then on the processing side, I have this very basic sketch that all it does is when I click the mouse, it draws a little circle wherever the mouse was, and then that circle kind of fades out. It also logs the coordinates of the mouse. So our goal this week, our main goal, is we want to send data from processing to Chuck. OSC can go either way. You can send from Chuck to processing, processing to Chuck, Chuck to reactor, whatever. Like, it doesn't matter. You can send it from whatever to whatever. But to keep things simple, all I want to do is send from processing to Chuck. And my goal is to send an event when I click the processing sketch with the X and Y location of the mouse. And I want to send that to Chuck and sonify that in some way. So, the first thing we need is the OSC P5 library. I already have it installed as OSC P5. What you will likely need to do is go to Sketch, Import Library, Add Library, and do a search for OSC here, and you'll see OSC P5, and you'll be able to click Install. Once you have that installed, you should then, in your examples folder in processing, have a new little section called Contributed Libraries. In here, you'll have a folder called OSC P5, and in here, you'll have an example called OSC Send Receive. This is the simplest example I know. OSC is a complicated protocol. It can do a lot of things. It's basically just, network protocol. It's basically how the internet works. So it can do a lot of different things. This is the simplest example I know, OSC Send Receive. Open this guy up. It looks a little scary, but it's not so bad, really. I'm going to go through it line by line, and then we'll copy it in and kind of integrate it ourselves. So the first things is we import OSC P5. Oh my God, you need to be able to see my face. Is we import OSC P5 and we import net P5. These are just two libraries. Import means take the code from that library and put it in our sketch so we can use it. That's all. So we're going to import these two libraries, OSC P5 and net P5. We're going to create a new OSC P5 object. Remember how classes work in processing? We have to Walker equals new, Walker W, and then later we say W equals new Walker or whatever. Exactly the same. OSC P5 and then lowercase OSC P5. This is our instance of the class. And they make a net address called my remote location. More on that later. They set their size and their frame rate, and then they instantiate the OSC P5 object as a new OSC P5, and then the keyword this and the number 12,000. We'll do this first. We'll do the keyword this first. So in processing, the keyword this refers to your current context, your current sketch, basically the current sketch that's running. We never really have to care about this in user land, but in library writing land, they don't necessarily know what sketch you're running. They don't have all that information about the size of your window and the color and stuff. But they can get it out of this keyword. So that's what this is for. You don't really have to think about it, just pass it in. It's always going to be that. The second argument, 12,000, is the address that processing will receive on. It's very important to understand that. The address that processing will receive messages on. For our purposes this week, we're not receiving messages in processing, we're sending them. So I don't really care what this number is. It really doesn't make any difference. But you need to put a number in there. So 12,000 is what they've chosen. Next week, if people are into this and actually do the work this week, then, no judgment. I know the world is crazy and, you're taking fucking Zoom classes. So I understand the assignment submission rates have dropped some. I would like people to submit work. I would like people to try to do the work. Mainly just because we can't do anything cool if no one does any of the work from the week before. So if people do the work this week, then next week we can do audio analysis and visualization, which will involve OSC from Chuck into processing for visualization. If no one does the work, I'll just make more granular sense, man. So 1200 is the receiving address for processing. I don't care about that this week. I'm not sending anything to processing, but we need to put a number. So 12,000 it is. Next, they instantiate my remote location as a new net address with this IP address, and then 12,000 again. They have this helpful comment here, which we can read together. My remote location is a net address. A net address takes two parameters, an IP address and a port number. My remote location is used as a parameter in OSCP5.send when sending OSC packets to another computer, device, or application. Usage see below. For testing purposes, the listening port and the port of the remote location are the same. Hence, you will send messages back to this sketch. This can be a little bit confusing, and when I did this as a student, and when I've taught it since, getting OSC to be correctly wired up and sending from the right port to the right port has always caused a lot of problems, and many sleepless nights, and many stressed out students running around the morning of Digital Arts Expo. So I'm going to make this as clear as I can. The remote location is the address that you are sending to. This is the example we always use because it's the simplest example, but it is more confusing because in this case, the remote location and the receiving address are the same because they want to receive data from themselves. They want processing to send to itself, as an example. It makes it more confusing though. So I just want to make it absolutely crystal clear. The net address is where we are sending data. So that's what this 12,000 here is for. We will probably not use 12,000. We'll use something else. The other argument, this IP address. IP addresses refer to machines, computers, or machines that are connected to a network, to usually a router. Machines that are connected to a router. If you go on a Mac, for example, into the Network tab in System Preferences, you will see your local IP address this is the address of your machine on your router. So mine is 192.168.86.103. That's my address on my home router. It's not my address on the internet. My address on the internet is just my router's address. That's the only access I have to the internet. But this is my address on my local network. I could look that up and send messages to myself with that, but to make it easier, the special address 127.0.0.1 always refers to yourself. So whatever computer you're on, whatever device on a network you're on, if you send messages to 127.0.0.1, you are sending it to yourself. So we always use that. It's also alias to localhost a lot of the time. And if you do web development, you'll see localhost. You could go to 127.0.0.1 and it would be the same thing. That's kind of the gist of how this works. So this is the address, this is the IP address on the network we're sending to, ourself, and this is the port, the OSC port we're sending to. So we could have thousands of things on the same computer all sending OSC on different ports or the same ports or whatever. It becomes clearer once we start to do it. Then they do some draw stuff, not very much, they just set a background. Then they have this mouse pressed method. So whenever the mouse is pressed, they create an OSC message, my message, instantiated as a new message with an argument of /test. So in addition to the IP address that's being sent to, the port on that IP address is being sent to, you also have, each message has an address. Much like if you went to calarts.com, right? The main address is calarts.com. That's like the IP address and the port kind of rolled into one. Then you might go to calarts.com/music or /film. That would be like the address of the message itself. Maybe that's a bad analogy. It's just another identifier on top of this. So once we get our communication going of Chuck is on this port, on this network, and blah, 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 we can send messages with names like /test or /click or /filter frequency or /play note, whatever. They then add some data to the message. So they add the number 1234 to the message, or 123 to the message. So in addition to sending a message with a name, we can add some numbers to it. They add this number 123. And then they call OSCP5.send my message, which is the message, and my remote location, which is the address we want to send to. So they want to send this message to this location. Let's build that out in processing now. And then we'll build the chuck side to listen to it, and fingers crossed it will all work. So, don't delete anything, Dexter. So this is my code. We're just gonna go in and copy line by line. So we want to import this stuff, right? We want, we can just type it out. Might as well. Whenever I'm learning something new, I always type things out rather than copying and pasting. It just makes it stick in my head better. So OSC P5, and net address. And I'm not going to call it my remote location because I think this is confusing, but I'm going to call it chuck address. And I'll put some comments so I remember. So this is the OSC library instance. And this is the address of chuck. Then we have to instantiate, right? So we're going to instantiate OSC P5 equals new OSC P5. This, and we can use 1200. Doesn't really matter. Again, we're not listening on processing in this week, so it really doesn't matter. And then we want my remote location, which we've called chuck address, right? Equals new net address 127.0.0.1, and the port we want to send to. So we don't want to send to 1200. That's our own port. We want to send. I'm just going to send to 1201. You could send to any number of your choosing. There's probably some max, but I don't know what it is. Okay, so that's that set up. And now in mouse pressed, in addition to drawing our rectangle, let's create an OSC message, and we'll just call it message equals new OSC message. And we're not going to call it /test, we'll call it /click because that's what we're doing. For now, I'm not even going to include any data. I'm just going to send a message when we click. So then we will call OSC P5.send message chuck address. Send my message to Chuck. And obviously Chuck isn't listening for anything yet, but we'll boot this up and just make sure it doesn't crash, right? It still works. You'll notice when we start this up again that it takes quite a long time to boot up because it has to start all these web server things. So it'll take a little second to wake up. Boom, bam, boom, bam, boom. Good, good, good. Okay, so that looks fine. Let's do the Chuck side now. So if you go into Mini-Article and you look for the OSC example, there is one there and it works fine. There's multiple ways to do OSC and Chuck. There's multiple APIs. And I like this one that's actually in the docs, but I don't think there's an example for it. So all you got to do to find there is I just searched in Google Chuck OSC, and I found it straight away. In this events page, scroll down. After MIDI events, we've got OSC events. And we can see the pattern here is actually quite similar to the MIDI pattern, right? We create some and the HID pattern. So I'm going to comment out the HID stuff because we're going to replace it with this OSC stuff. So we create an OSC receive, RECV, and I'll call it OREC as they do. Then it needs a port, right? What port should it be? It should be the port that processing is going to send to. So processing is going to send to Chuck address, right? Which we've said is port 12001. So its port should match. Give me that. So 12001 chuck to orec.port. Then we call orec.listen. And I like to throw in a little log as well. So I'm going to do a little log that just says now listening. Just so I know it's listening. Okay. Now, the OREC, the OSC receive, will create events, like MIDI events, you know, it will create events we can wait for. And it will create one for each type of message we want to listen for. So we need to create one of these. So we say orec.event, and we tell it what we want to listen for. So we called our message /click, right? If I look in processing, down here, /click. That should map to that. So orec event /click. Sorry. And I'm going to @chuck that to OSC event. I'll just call it E. So we're going to chuck that into an event that we can now wait for. Then if I do a while true, while true, E chuck to now. This is similar, right? This is how MIDI works, right? E chuck to now, and then we do while E.next message, or sorry, MSG for message as a function call does not equal 0. So while we have messages to read, in this block here, we have received a message. So for now, I'm just going to log some exclamation marks. And fingers crossed, everything will work out. We got a syntax error. What did I do? What did I do? What did I do? Line 47 is here. Yep, forgot a semicolon. So let's run this. Okay, it's listening. Fingers crossed. Say a prayer. This is all going to work. So if I now run my processing code and I click in processing, haha, if I click in processing, I see logs coming out on the chuck side. So it seems like they're listening to each other. And just to be extra sure, I can take my little play note line. Oh my god, oh my god, oh my god. Play note line. And make it so that when I click, we're kicking out grains. We did it. We did it. Never have I been so happy. But we can do more here, right? There's more to be done. There's more interesting things to be done. And they don't take a lot of extra effort. So ideally, what I would want to do, right, is I would want to not just send that there's been a click. I want to send where the click was. So I want to send the mouse X and the mouse Y location. And that is actually incredibly easy to achieve. All I have to do is say message.add mouse X and message.add mouse Y on the processing side. So in addition to it being this click message, we've added some data to it. If I run now, oh no, nothing works. So there's actually something we need to change on the chuck side as well. And it's not immediately obvious what that is. But this line here, where we get it back, where we click, this is actually more complicated than it seems. So the address of the OSC event is not just the /click or the /whatever. It's actually also includes the type of data that will be sent and how much data will be sent. So when all we were doing was we weren't sending any data, just click was fine. But now that we're sending 2 integers along with data, click, our address has changed from /click to /click, comma, II. I standing for int, we're sending 2 ints. /click, comma, II. And now if I try this again, if I run my chuck code, okay, we've got messages coming in. And I can then in here say something like, let's log x, and we'll log e.getInt as a function. And y is e.getInt as a function. So when we call this getInt, we're pulling things out one at a time. So we pull the first thing out, which is our x, and we pull the second thing out, which is our y. If I run this again, if I click around, you can see I have x and y locations coming in to Chuck from processing. So up at the top left, right, this should be like 00-ish, close enough. And at the bottom should be 640, 640. Should be pretty close. The most important thing, right, is at 635, 635, this matches in processing where we're logging the x and y. So we're doing good. So what can we do with this? Anything, right? The world is your oyster. You're just sending numbers. My immediate instinct is to do something like either volume or panning or something, or pitch, or just some standard parameter. But I'm going to do a really, oh my god, sorry. I'm going to do a really quick quality of life improvement for us. And right now we're sending a mouse x and a mouse y. And if I want to scale that value and kind of use that value intelligently, Chuck needs to know how big the screen is and stuff. So I could just say, I could tell Chuck the sketch is 640 by 640. But then I have to change it if I want to make this sketch bigger. That's a pain in the ass. So what I'd rather do is I'm just going to send mouse x and mouse y as floats from 0 to 1. So if it's 0, I'm on the left. If it's 1, I'm on the right. If it's 0, I'm at the top. If it's 1, I'm at the bottom. Then I don't care how big the screen is, and I can just scale these things to whatever they need to be really easily. So we'll just log first how we're going to do this. So I'm going to take mouse x, and I'm going to divide it by width, right? And mouse y, and I'm going to divide it by height. And I'm just doing this in the print line in mouse pressed. Now let's see what happens if I run this. We see I'm always logging 0. And this is our old friend floating point division again, that if you divide two ints, it'll always give you an int back. So we're always just going to get 0. So the easiest way to fix it is just to multiply width by 1.0 in parentheses. So it's mouse divided by width times 1.0, mouse divided by height times 1.0, and that forces height to be a float and width to be a float, so we should get floats back on our division here. This isn't a processing class, so I'm not too concerned with going over the intricacies of that. I think you've all had enough experience at this point that you should be able to follow, but now we can see I'm clicking and I'm getting floating point numbers out. So I'm getting it should be kind of 0, 0-ish over here, yeah, pretty much. 1, 1-ish over here. Yeah, close enough. Cool, cool, cool. So now I want to send, rather than adding mouse x and mouse y, I want to add these kind of complex lines with the division in it, the scaled mouse x and mouse y. Run this. Run my Chuck code. And okay, it doesn't work, right? And the reason it doesn't work, I hope is, becoming clearer, starting to materialize, is that this address pattern, right? We said we're going to get 2 ints. Now we're sending 2 floats. So rather than II, this should become FF. And rather than getInt, we want to get float. And now we should get our messages across again. And we get these nice values, these nice ranges here. So let's map them. Let's say, now we're just back in audio programming world. It doesn't really matter. That's the end of the communication lecture. But let's say we accept also a float x and a float y. And I don't know, we'll make, let's make our loop time be dependent on, so that's this, right, t. So this will be dependent on x. So x is from 0 to 1. So let's say this is actually going to be x times 500. So if we get x as 0, our time will be very close to 0. Maybe we'll make it just so we don't freak out, we'll just do x plus 0.01 or something, just so we don't ever get a 0 and crash. So x times 500, so if we get ones, we should be getting like 500 milliseconds, and if we're getting zeros, we should be getting very fast repeats. So let's try that first. And we'll pass into our line here. Sorry, this line is getting a bit long and confusing. We'll pass in x and y, which I need to define up here as float x equals e.getFloat, and float y equals e.getFloat. And it's important here that you can only call getFloat, like each time you call getFloat, you're making a change, like you're getting that float from the message. And if you call getFloat again, you're gonna get a different one. So I can't log them with getFloat beforehand. Hope that makes sense. Don't leave those logs in or things won't work. So x is getFloat, y is getFloat. We'll pass in x and y. Rerun, got a problem on 47. Yep, because I forgot that we're writing chuck code. Chuck to float x, chuck to float y. Sorry about that. Okay, types float and int. Yes, I said that the arguments are floats. Oh yeah, and then t should become a float. Okay, we're now listening, and hopefully if I click to the left, if I click really over here, we get really kind of grainy, like fast loops, and if I click over here, we get really slow loops. Sick. Take that, Steve Wright. So, shut up, Chuck. So now let's just get y involved here, just to make something more, more playable. And let's just say y maps to pitch roughly, right? So let's say, y is going to be between 0 and 1, and I want to spread out amongst an octave. I'm not even going to pass pitch here. I think I'm going to delete this note argument. And I'm just going to use note based on y. I'm going to create an int note, and we're going to need to do some math to figure this out. So I want to say, how are we going to do this? I basically want to, let's increase my amount of allowed notes. So we also want, just the octave is fine. Okay, so what do we got? We've got 7 things in here. So yeah, 1, 2, 3, 4, 5, 6, 7. Cool. So we do have 7 things in there, thankfully. So we need our value of note, which is between 0 and 1, to map a range 0 to 7, right? So this is going to become, we can scale that range, right, by saying y times 7, right? So that takes 0 to 1 and makes it 0 to 7. We want to use it as an array index, so it needs to be an int. So I'm going to cast it to an int like this with the $, and I'm going to do scale that chuck to int note. Hopefully that works. It might work. And then note just gets passed in there. Save all that. Scale is used for declaration. Yeah, let's move scale up. which is already defined when we define the function. Okay, so hopefully now if I click at the bottom, we're gonna wanna do an offset on that, so we're not sending MIDI note 0, so excuse me about that. Let's make this like 50 plus. Okie dokie. So now hopefully if I click at the bottom, we'll be getting low notes, and at the top, we'll be getting higher notes. Oh yeah, inverted. So if just for me, in my head, like thinking musically, like I want that to be the other way around. So I'm just gonna do 1.0 or 1 minus y rather than y. And that should flip the range. Okay. And we still get like slow loops over here and fast over here. Maybe it'll stop eventually. Okay. That is like as far as I want to go with this today. What we've done is we've created a basic interface in processing that allows us to click. We could have done a lot more. And we've sent OSC data from processing into Chuck to trigger notes. The important thing about this week is to have this OSC communication thing working. All I care about is that you have OSC communication working. So the assignment is going to be very simple. You can go as far as I did, you can go further than I did, or you can go not as far as I did. You can, just as long as you have some notes, some events, some data being sent from processing to Chuck, I'm good. That's all you need. And like I say, next week, if everyone has that, we can like dive in to audio analysis and bust out FFTs and RMS and all this stuff and send that data from Chuck into processing, and it will be pretty easy. But people have to already have this groundwork in. So that's the goal this week. I would encourage you to push yourselves and kind of make something interesting. I think it opens up a lot of cool things really quickly to start doing this and start having this communication like be there between Chuck and processing. I would definitely, like a cool idea might be if you took like some of our, remember last semester when we did processing, we were doing like balls that would like bounce, right? They would like bounce around the screen. That would be amazing, right? You could do whenever it hits a wall, in your bounce function, send an OSC message to Chuck. So when it hits the wall, it bounces and like makes a sound. Awesome, amazing. I would love that. Then you have like a chaotic sequencer, right? That sort of stuff is really cool and really creative. If you want to just re-implement what I've done, also fine. Throw your own sample in, play around, change the range, change the notes, whatever you like. But that is, I don't want to put a ton of work on you, but all that I care about is that you have this communication between Chuck and processing down. So yeah, thanks for watching. I'm gonna try to edit this video into something that makes sense. And yeah, we'll do our Zoom call on Wednesday. I'll be in it, I think probably just for 1 hour. So you have an hour to watch these lectures and then an hour to hang out in Zoom if you want. No pressure. And please email me if you have questions. Don't fall behind. Don't get stuck. And you know, the world's gone crazy and we're gonna like figure out how to get through this semester in the best way we can. So hit me up. I want to help. I will see you all maybe on Zoom or, you know, when I see you. Okay.